Question 1. We have to first solve the inequality 14n is greater than 11n plus 6. So I'm going to take 11n from both sides. So that gives me 3n is greater than 6. Then divide both sides by 3. And that gives us n is greater than 2. For part B, if we split this inequality up into two parts, and then we took 3 from both sides, this would isolate the x term in both cases. Then it's almost like we took 3 from each individual part, because if I put these two back together again, this is my end result. And if I want to show this on the number line below, then I have -5 here. I've got 1. It can be equal to 1 here. So I'm going to do a dot which is coloured in, but it can't be equal to -5. So this would be what I would show on the number line. I could do that on top, but it's just easier just to put it a little bit below. And I'll also write in the numbers just so we've got everything there that the examiner wants to see. Question 2. On the grid below, we've got to draw the graph of y equals 2x minus 3 from -2 to 4 with our x values. So I'm going to do a quick xy table. Start with -2, finish at 4. I'm going to put x is 0 first because that gives me the nice one, -3. I know the gradient's 2, so it's going to go up by 2 every time I move forward 1, which is a handy thing to know. Saves a lot of time. And if I go back this way, I just go back by 2. And then I'm just going to plot these points. So 0, -3, that's the y-intercept. And then 1, -1, 2, 1, 3, 3, 4, 5, and then -1, -5, -2, -7. We didn't have to do all of those points. We could have, say, done this one here and then just gone along 1 and up 2 and maybe got away with drawing our line all the way through just using 2 points. But it's best to do as many as you can if you've got the time. Just quickly drawn in the line. And there we have it, y equals 2x minus 3. Question 3. Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go, and each student chooses one place. And we've got some information in a table. We've got to work out how many of the 195 students you think will want to go to the theme park. Well, if we add these numbers up here in terms of their choices, that's 30 choices altogether, and 10 of those said they wanted the theme park. So I would say 10/30ths of 195 would be my best estimate for how many I think would want to go to the theme park out of 195. So 10/30ths is 1/3, so I can just do 195 on my calculator divided by 3, and that's 65. So I'm going to put that there. Now, part 2 says, state any assumption you made and explain how this may affect your answer. So I've written my answer. I said I assumed that the sample in the above table represents all of the 195 students, and I've said there may be, of course, more or less than 65. Question 4. A container is in the shape of a cuboid and the dimensions are given. It says the container is 2/3 full of water and a cup holds 275 mils of water. What is the greatest number of cups that can be completely filled with water from the container? So let's work out the volume of the container first, and that is 19 by 6 by 30. So we've got a calculator here, so 19 times 6 times 30. And that gives us 3,420 centimetre cubes. And we want it to be 2/3 full. So 2/3 of the volume of the container is 2/3 of 3,420. So I'm going to times it by 2 and then divide by 3. And that's going to give 2,280 centimetre cubes. It says what's the greatest number of cups that can be completely filled with water from the container. Don't forget they're 275 mils each. So we need to be mindful that 1 mil is the same as 1 centimetre cube by volume. That's of water, that is. And so all we need to do is 2,280 divided by 275. So I'm going to do that now. And that's going to give me 8.290 recurring. So the greatest number of cups that can be completely filled is going to be 8 full cups. Question 5. ABC is a right-angled triangle. We're given the angle BCA is 38 degrees and we're given the hypotenuse is 16 centimetres. Without going into too much detail about how trigonometry comes about, I'm going to just write down SOHCAHTOA, which a lot of you would prefer me to use, rather than going from first principles. So what have we got here? We've got an angle, we've got the hypotenuse, and we're asked to calculate AB, which is opposite the angle. So we're going to use the opposite and the hypotenuse, so that is sine. So sine 38 is going to be the opposite, which is AB, divided by 16, which is the hypotenuse, and then times both sides by 16 to get AB. So AB is going to be 16 sine 38. Set your calculator into degrees, and so 16 sine 38. On the calculator, I would write down the whole display. And then round to 2 decimal places. 9.85 centimetres to 2 decimal places. Question 6. Sally used her calculator to work out the value of a number y. The answer on her calculator display began with 8.3. So we know this has to be 8.3 here. And we've got to complete the error interval for y. So what could y have been? Well, the highest it could have been is, say, 8.3999 going on forever, or 8.39 recurring. So because we've got a less than sign here, then what I'm going to put in for the final part is 8.4, because this says it could be anything up to 8.4 but not including it. So that would have covered 8.3999 with an infinite amount of nines afterwards. So I would go between 8.3, which it can be, it has to be starting with a 3, and all the way up to but not including 8.4. Question 7. £360 is shared between Abby, Ben, Chloe and Dinesh. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. And Chloe and Dinesh get 1.5 times the amount Abby gets. So if Abby gets 2 parts, you just times that by 1.5 and you get 3 for each of those two, because they both get 1.5 times the amount that Abby gets. It says work out the amount of money that Ben gets. Well, if we look at these, we've got 2 and 7 is 9, and 3 is 12, and 3 more is 15 parts to this ratio. And the amount of money that has to be shared is £360. So if we do 360 divided by 15 on our calculator, we get 24, and that's for 1 part. So if we want to work out how much Ben gets, then yes, we do 24 times 7. And that's going to be £168. I'll just check on my calculator. Yep, £168. Question 8, we have to write 0.00562 in standard form. Well, we look for the number between 1 and 10, and that's 5.62. And we say to ourselves, has 5.62 been made larger or smaller? Well, it's been made smaller. So if we imagined there was our 5.62, we'd have to divide by 10 once, twice, 3 times. So that means we're not timesing by 10 to the power of 3, because that would be timesing by 10 3 times. We were dividing by 10 3 times, so it's 10 to the minus 3. The next part says we have 1.452 times 10 3 times. So we imagine we have 1.452 and we're just timesing by 10 once, twice, 3 times. So that would be 1,452 as an ordinary number. Question 9. It says the circumference of circle B is 90% of the circumference of circle A. Well, let's have a look. So if we have the circumference of circle A, let's say that is C, then circle B is 90% of that, so that will be 0.9 C. And we want to find the ratio of the area of circle A to the area of circle B. Well, let's have a look at the ratio of these in terms of circumferences, which is lengths. If I want to simplify this, I can times both sides by 10 and divide both sides by C, and that would give me the ratio of 10 to 9 as a length. So as an area, we just square a length, don't we? Because it's in units squared. So as an area, we would have 10 squared, which is 100, to 81, which is 9 squared. Now the next part, we're given square E and square F. In terms of their lengths, we're told that E has lengths E, small e, and F has lengths of small f. Now, the area of square E is 44% greater than the area of square F. So in terms of areas, we have F squared for this one, and the square E is 44% greater than that, so we just times it by 1.44 as a multiplier. So we can divide both sides by f squared and we get 1.44 to 1. Now that's as an area. If we want the ratio of e to f, then we've got to be talking lengths here. So to get from an area to a length, we just do the opposite of squaring, which is square rooting. So the ratio of e to f is going to be the square root of 1.44, which I can do on my calculator, which is 1.2, and the square root of 1 is just 1. Now I want that as a ratio e to f. I don't like decimals in terms of ratios, so I'm going to times both sides by 10. So that's 12 to 10. And then I'm going to halve, and that will give me my final answer of 6 to 5. Question 10. Mary travels to work by train every day. The probability that her train will be late on any day is 0.15. So we can fill those in. And we've got to complete the probability tree diagram for Thursday and Friday. So these must add up to 1. So these will be 0.85. You can do 1 minus 0.15 on your calculator to get that. And the last one here. It then says, work out the probability that her train will be late on at least one of these 2 days. So let's have a look. Well, to be late on at least one of those days would be to get to here, and here. So even if it's late twice, that's still at least once. So what I'm going to do is I'm going to work out the probability of not being late on both days and take that away from 1, and that will automatically give me what I need in one go. It just saves time doing all of these 3 when you can just do 1 minus this outcome here. So the probability of not being late on both days would be 0.85 times 0.85. So on my calculator, 0.85 squared is 0.7225, and so the probability that I need, so the probability of, let me just say, late at least once will be 1 minus 0.7225, and my calculator says, and I'll write that here so you can see it clearly, 0.2775. So let's just see how many marks that was worth. That was 3 marks just for that part. Question 11. The grouped frequency table gives information about the times in minutes that 80 office workers take to get to work. We've got to complete the cumulative frequency table. So it starts with 5, then we add 30, then 20 more, and then 15 more, and so on. It then says, on the grid, draw the cumulative frequency graph for this information. So we're going to look at these endpoints and plot them against the cumulative frequency, noticing here that it starts at 0. So we're going to start plotting at 0. I think on the mark scheme they ignore things before the first point and after the last, so I wouldn't worry too much, but we're going to do this. So 0, 0, and then 20 versus 5, like so, and then we're just going to complete all the others. I'm then going to draw a nice smooth curve through all of those points carefully. I did that as best as I could. You can probably do better yourself. And then it says use your graph to find an estimate for the percentage of these office workers who took more than 90 minutes to get to work. So the 90-minute mark is here. We're going to draw a dotted line, you would use a ruler in the exam, and you must show this dotted line in the exam. You've got to show as much workings as possible. And this gives me 75. So that means there were 5 out of the 80 who took more than 90 minutes. And as a percentage, all I do is I do 5 divided by 80 on my calculator and then times it by 100, and I get 6.25%. And just before we leave this question, I'm going to stress again, please show these dotted lines, they're really, really important. Question 12. AOB is a sector of a circle with centre O and radius 7, and it says the area of the sector is 40 centimetre squares, and the area of a sector is like the area of a circle, but we need to know what fraction that angle is out of a whole turn, because a whole turn would just make a circle, and then we just do the area as normal. So it's pi times the radius squared. So pi r squared would just be the area of a circle, but we want to know what fraction it is, and we're given that the area is 40, so it looks as though we just have to find this angle first, and then I guess we can do the next part of the question. So I'm just going to simplify a few things. And then a little bit more. And then I'm just going to rearrange to get theta, the angle. So I'm going to times both sides by 360 and then divide both sides by 49 pi. And then on my calculator, I'm just going to do that calculation. So I've got 40 times 360. I'm going to write out every step because it's good practice if you're not confident to do the top part first and then do the bottom part separate. So 49 times pi, and on my calculator it says this. That would be approximately, because I've approximated this. And so 14,400 divided by 153.93804, that's going to give us theta as 93.544,12982 degrees. So that's the first part of the question. We now need to calculate the perimeter of the sector, so all the way round. So first thing is, don't forget these here. That would be a common mistake, I would say. So let's change the colour of the pen. So the perimeter is going to be 7 plus the fraction of a circle, that's not very good, the fraction of a circle which this circumference would be. So this is going to be in proportion of this angle, which we now have, over 360 of the circumference of a circle radius 7. So what is the formula for a circumference of a circle? Well, I'm going to use 2 pi times r, so 2 pi times 7 in this case, and then don't forget I've got to times it by, in proportion, the angle that we've just found out of 360. That's like the fraction of what the circumference would be. Okay, so I've got my angle in my calculator. Some of you can use that function. It's called ANS on some calculators, or the store function. If you don't have it, then just write that out and put it in its place. Don't round the angle before you put it in. Okay, so 7 plus 2 times pi times 7 times ANS in my case, because that's the answer I've already got in my calculator, and then divide by 360, and I get the perimeter as 25.42857, and then it goes 143. I think all that means is it's 428,571 recurring, because then it goes 42 and then it's just rounded that 3, so that's what it would be. But we want it to 3 significant figures, so the perimeter is going to be 1, 2, 3 significant figures. That's 25.4 centimetres, and I'm going to write 3SF there. So if some of you are stuck with that, then just do each part in turn. So write that as 14, work that out as a decimal, then times it by your 93.54412,982, and then divide by 360. So you've got like 14 plus this part separate. So only put the whole thing in if you're really confident with BIDMAS or BODMAS, the order of operations, okay? Or you could make a mistake. Question 13, we've got an expression here. It's quite difficult, actually. I can see that this would scare some people. I'm going to put an extra bracket here just because it helps me visualize what's where, okay, and one there, and then close this off. And the first thing I've got to look at, I'm not even looking at this part just yet. I'm trying to work out what factorise is in here, because we've got to simplify it, and it's going to be definitely to do with factorising this. So we know we've got to get it in this form, but let's do a little bit of work first and see if it starts breaking down. So we've got 6 plus, then a square bracket. The first thing is, if you're dividing by a fraction, then it's the same as timesing by the inverse. So you basically flip this fraction here. For those that are more confident with their algebra, you'll probably say to yourself, well, hold on, this is like having the dividing line going all the way through because it's under multiplication. So I'm either looking for an x plus 5 in here, which would simplify, wouldn't it? That would cancel, or an x minus 1. So looking at x squared plus 3x minus 10, I know if I did a table here, I would have an x with an x, and then factors of 10, which give 3. Well, I'd have a 5 and a 2, and I'd make this one minus and then this one plus. So if I multiplied it out, I'd have x squared, 5x, minus 2x, and minus 10, which is x squared, minus 2x, and 5x is the 3x that I want in the middle, and then minus 10. So writing this out, I have x plus 5. I'm going to omit this multiplication sign, it's just implied. And then underneath here, I've just got the factorised. I really should make these a little bit longer. So that's one of them, and then the other one. And then I've got x plus 5, and then x minus 2. They come from this part here. So looking carefully at what we have an x plus 5 here, an x plus 5 here, and x plus 5 divided by itself is just 1. And then I've just left with here in the bracket x minus 1 over x minus 2. Now I'm going to start looking at here. So it just wants it as one fraction. It doesn't want it as a number plus another fraction. So I'm going to create a little bit more room. And let's see where we can go. So I've got 6 plus x minus 1 over x minus 2. I'm going to get the denominators the same. So timesing top and bottom here by x minus 2. That means I've got a common denominator of x minus 2. And I'm just going to multiply this out. So I've got 6x minus 12 and then plus x minus 1. And that's going to give me 6x plus x is 7x. Negative 12 take away 1 is negative 13 over x minus 2. That's now in the form ax minus b, cx minus d, where a is 7, b is 13, c is 1, and d is 2. Question 14. A car moves from rest and the graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. So we're given a velocity time graph and we can see a nice smooth curve here. We're asked first of all to calculate an estimate of the gradient of the graph at t equals 15. So if you look, I've already done this. So you read along t equals 15. You draw a nice straight line so it just touches the graph, the curve, at the point where t is 15. So practice that. The answer which the mark scheme gives, interestingly enough, is 0.83 to 2 decimal places. So I've tried it a couple of times and I can get to around 0.8. You may be able to do it better. I'm not saying that's the perfect answer, but there will be a tolerance. So I'm sure you're allowed something like, I don't know, 0.75 to 0.85, something like that. It could be even wider, the tolerance. I think the main thing is as long as you show what you're doing, that's the most important thing. So once we've got the idea that we just have to really show our workings and our method, we've drawn our tangent at t equals 15. We've then got to work out the gradient. So we look at the change in y over the change in x. So we try and draw a triangle to show that because the straight line has the same gradient everywhere along it. So to get a good estimate, I would make your triangle reasonably big and kind of centre it around the point t equals 15. So push out a little bit to this side and up a little bit to this side, just so you're not too close to that point. So don't go drawing a tiny little triangle because you'll probably get more error. So what I did, I looked at the scale, so be very careful by reading the scale properly. So it's 2 little squares for 1. So I worked this out to be 9.5. I worked this out to be 12. And I showed the dotted line carefully. You'd use a ruler in the exam. And I just did the change in y over the change in x. So 9.5 divided by 12 on the calculator. So let's have a look. 9.5 divided by 12, and that gives me 0.7916 recurring, so I'm going to say 0.79 to 2 decimal places. Okay, so let's move on to the next part. It says describe what your answer to part I represents. So what we had was 9.5 divided by 12. But what was the 9.5? What were the units? Well, if we look, we had the speed here. So this 9.5 is a change in speed. And speed is meters per second. And we were dividing that by a change in time, which was in seconds. So the dimensions there, or the units that we used in that case, were seconds. So if you look carefully at this, meters per second divided by seconds, Well, that's meters per second times 1 over seconds, because when you're dividing two fractions, you can turn this one upside down, so to speak, or find the inverse and then change this to a time sign. There's a lot of reasoning behind that. I'm not going to go into it now. So basically, you'll be left with meters over seconds squared. Another way of saying that is meters per second squared. So meters per second squared, well, that's an acceleration. Acceptable answers would be something like rate of change of speed or increase in speed over time. They would be okay as well. But it's best to just go with the dimensions, go with the units, and then you can kind of see for yourself. And you probably have seen meters per second squared before, haven't you? I don't know if you've seen this. That's another way of writing the acceleration in terms of its units. The next part of the question says, work out an estimate for the distance the car travels in the first 20 seconds. Well, what does that mean? If we wanted to look at the area underneath this curve, say we took one of these boxes here, what would the area of that be? Forget the actual number, look at the dimensions. So one of the dimensions would be going this way, so this would be to do with speed, so that would be meters per second, and the other dimension would be going this way. Okay, so the first one was going this way, which was the speed, which is meters per second, and the other length of this square is going to be seconds. So you know how to find the area of a square. You just multiply the two lengths together. And don't forget they're different units, but they're the same number, okay? So be aware of that. So we just want to find what the unit of area would give us. So it would be meters per second times seconds. And can you see that they cancel out and you're left with meters? So basically, all of these areas are worth meters. And that's why the area under a curve represents the distance travelled, and that will be in meters, okay? So, how do we work out the estimate? Well, it asks us to use 4 strips of equal width. So as you want to go up to t is 20, I'm going to do a dotted line here. Of course, you'll use a ruler. And then the only way I can get it as 4 strips of equal length is to go up in 5 seconds. So, how could I estimate the areas between those dotted lines? Well, I'd have to estimate them as trapezia in the first instance. And this one I would look at as a triangle, okay? A right angle triangle. So here's what I'm going to do. I'm going to do this quite slowly because I know this is quite tricky for a lot of people. So what I've done, I've already carefully worked out that these are all 5 and the height's 4. This doesn't have any height, so that's why we're saying it's a triangle. We could say it's a trapezium where we've got 0 height here, but it's, we'll use a triangle formula. So I've got 5 times 4 over 2, which is the area of this one, and I've labelled it as 1. Then the area of a trapezium, don't forget the formula goes h over 2 lots of a plus b, okay, where a and b are the lengths of the parallel sides, and h is the common height to all of them, which is 5 in every case. So after getting these lengths done, and I think the graph's done really nice because they work out as nice whole numbers, you can just put that into the formula for each of the trapezia and you'll get 40, 75 and 95, the area of the triangle being 10. One thing to mention for those that want to do this even quicker, and I know it comes up at the A level, is for the trapezia, you could say that when you look at the trapezia, we've got 1, 2, 3 of them. These two share the same height, and these two share the same height. So what you could say is something like this. You can take the 5/2 out as a common factor, so you can say it's 5/2 lots of one of these, because that's only used once, but 2 of these 12s are used, 2 of these 18s are used, and then just 1 of the 20s. So you can just put it all together really quickly. If you had like another 2 trapezia, you could just say, and this is how I remember it, especially when I've taught A level, is 1 of the first, 1 of the last, and twice all the ones that are shared, and then the common factor would be the height over 2. It's up to you if you like that. If you don't, it's fine. And so what we're going to do is, on the calculator, we're just going to simply add these areas together, and the answer is going to be in meters, don't forget. So we've got 10 plus 40 plus 75 plus 95, and that gives me a final area of 220 meters as our estimate. Question 15. We need to make m the subject of the formula, and we have f equals 3m plus 4 all divided by m minus 1. Well, the first thing I'm going to do is multiply both sides by m minus 1. Then I'm going to multiply out the bracket. And the way of doing these type of questions is to try and isolate the m terms on the same side. So it doesn't matter which side I choose here. I'm going to just take 3m from both sides to get them both on the left-hand side. Then I'm going to add f to both sides. And then I can factorise the m out. And then divide both sides by f minus 3. Let's change that, sorry, little mistake. So we have m is equal to f plus 4 all divided by f minus 3. Question 16. The line L has equation 3y equals 4x plus 7. This notation here just means L is such that, and then we've got 3y equals 4x plus 7. And the point A has coordinates 3, negative 5. It says find an equation of the straight line that is perpendicular to L. So the first thing to do is to make y the subject of the formula, and I'll divide both sides by 3. And the reason I've done that is because then I get the gradient and the intercept. It's kind of like, you remember y equals mx plus c, okay? Then you've got the gradient is 4/3 and the y-intercept is 7/3. Now, the best thing to do from here is, if you want the perpendicular, then because this is 4/3 here, there's a rule here that if you do m1 times m2, and that is negative 1, then this gradient and this gradient, they're perpendicular to each other, okay? So if you do 4/3, the only thing you can times by 4/3 to get negative 1 is negative 3/4, because the 3's would cancel, so would the 4's, and you'd be left with negative 1. So the line we want is, we want it to have this property where the gradient, because it's perpendicular to L, it would have the gradient negative 3 over 4, as we've already explained, and some intercept. And then the way of finding that out, as I'm sure a lot of you have worked out already, is to just substitute x is 3 and y is negative 5 into here. So if y is negative 5, we'll have minus 3 times 3 over 4 plus c. So negative 5 equals negative 9 quarters plus c. Get it all into quarters, so that's negative 20 quarters plus 9 quarters, because I'm just adding 9 quarters to both sides. And so c will be negative 20 plus 9, that's negative 11 quarters. So the answer will be y will be equal to negative 3 quarters x minus 11 quarters, because that was the missing link. Some of you would like to write that in a different way, and that's absolutely fine, because the question had this form. So if we multiplied both sides by 4, we'd just have 4y equals negative 3x minus 11, and that would just be an alternative to this form. So either or is acceptable. Question 17. There are some small cubes and some large cubes in a bag, and the cubes are red or yellow. And we're given the ratio of, I'm going to write this here, small to large is 4 to 7. And we're given the ratio of red to yellow is 3 to 5. And it says, explain why the least possible number of cubes in the bag is 88. Well, one way of looking at it is to say 4 and 7, that makes 11 parts. And if you look at 3 and 5, that's 8 parts. So if we look at the lowest common multiple, of 8 and 11, then that's going to be, which is y, that's the least possible number of cubes in the bag. Now, if you look at those ratio again, you can see that small to large, 4 to 7, 11 parts, and red to yellow, that's the ratio 3 to 5, 8 parts. If you times this all by 8, then you would get small to large is going to be 32 to 56. Okay, that makes 88 parts, and therefore if you times this by 11, you're going to get red to yellow is 33 to 55, which is also 88 parts. Now it says clearly work out the least possible number. Well, we worked out that the least possible number of cubes is 88, and that's why we made these numbers 88 here. So I'm going to give myself a little bit more room, and we're going to read really carefully what it's asking for. It says all the small cubes are yellow. Okay, it says work out the least possible number of large yellow cubes. Well, first of all, we need to be looking at this really carefully, because that will tell us that out of those 88, 55 are yellow. This number tells me that 32 are small. So if we do 55 take away 32, we're going to get 23 are yellow and large, which is the least possible number of large yellow cubes in the bag. So that is our answer just there. So let's see how many marks that was for. There you go, that was for another 4 marks. So I'm just going to write the answer clearly here, 23. Question 18. The points A, B, C and D lie on a circle. CDE is a straight line, and we're given some other information such as BA and BD are the same. So it's an isosceles triangle, we can see that, and it gives us the angle ABD is 40. We've got to find angle ADE. So we've got to find this angle here. So the first thing I would do is say that in triangle BAD, it's isosceles. So I'll write this up here. So angle BAD equals BDA, and they're going to be 70 degrees because we've already got 40 here and angles in a triangle are up to 180. So I'm going to say the reason is angles in triangle add to 180, and also triangle is isosceles. That's why we said the base angles are both the same. The second thing we can say is, once we've got these in, so let's mark them in, they're both 70. The next thing we can say is that this angle here is 110. So we can say that BCD is 110 degrees, and you probably can see why, and that's because angles that are opposite in a cyclic quadrilateral add to 180 degrees. So we can label this one in here, and that one is 110. Now if you look in the diagram, we've got another isosceles triangle here because BC and CD are the same, but we already have this angle is 110. So what we can say next, and I'll just give myself a bit more room, we can now say that triangle BCD is isosceles, and so therefore angles CBD is the same as BDC, and they're going to be, well, 110, and there's another 70 left between them, so there'll be 35 each. And you can say like angles in triangle sum to 180, we use that fact as well. So let's write those in. So we've got 35 here and 35 here. Now let's look a bit more closely at the diagram. Well, I think you can see it now, and that's because angles on a straight line, so we can say angles on a straight line sum to 180 degrees, therefore angle, now did they call it EDA? Let's have a look. ADE. So therefore angle ADE is equal to, well, we've got 70 and 35, that's 105, so there's going to be 75 left. And so that's going to be our answer. And if we look now at the marks for that question, you can see that it's 5 marks, okay? So we'll just write that a little bit more clearly so we can see it. ADE is 75 degrees.
And it's really important that you do spend the time writing these reasons. I know it's really boring to write them all out, but you really have to get all the marks. Question 19. The diagram shows a triangular prism. The base is a square 15 by 15. We're told that ABE and CBE are right angles, and we're given one of the angles EAB is 35. Now, the important stuff starts here. M is the point on DA, such that DM to MA is 2 to 3. So if DM to MA is 2 to 3, well, if we times both sides by 3, that's the same as 6 to 9, and 6 and 9 make 15, so we can put M here, and we can say this is 6 centimetres, and this length here is 9 centimetres, because together they make up 15 centimetres. Think about it, because the parts add up to 5, don't they? So if you times 5 by 3, you're going to get 15, which is the required length. So the next thing to do would be to join M up to E. So you use a ruler, obviously. I don't have that. So we're doing M to E, and then it says calculate the size of the angle between EM, which we've just drawn in, and the base of the prism. So we've really got this length, which is really key, and to make another right angle triangle using the base, we can just go from M to B. Okay, so first things first, step 1 is going to be to find EB. So in triangle AEB, which is right angled, we've got an angle here, we've got to find the opposite, and we've got the adjacent. So I'm going to use SOHCAHTOA, and we've got opposite and adjacent involved with the angles, so we're going to say tan of the angle, so tan 35 is going to be opposite, which is EB, over the adjacent, which is 15. So that means that EB times both sides by 15 would be 15 tan 35. I'm not going to decimalize that just yet. Now the next thing is we need to look at the large triangle, so we now need to look at triangle MEB, and we need to see, well, what type of triangle is it? Well, it's a right angled triangle. We're having to find this angle between EM and the base of the prism, so we'll call it theta. I should have mentioned that earlier. And to find that angle, we just need to work out 2 of the lengths. Now, we already will know EB, because we've already got it here. So my suggestion would be to find M to B, because again, it's a right angled triangle here, and we're given 2 lengths. So we can say by Pythagoras, because it's right angled, MB squared, which is the hypotenuse, is the sum of the 2 smaller. So it's 9 squared plus 15 squared, which is 81 plus 225. Of course, use your calculator if you don't know your square numbers. So 81 plus 225 is 306. So MB is the square root of 306. So underneath now, for those that really want to see the decimals, I'm going to do that as a decimal. And we get 17.49285568, and we're going to do this one as well for those that need it. So 15 tan 35, that's going to be 10.50311,307. So if we look at triangle MEB now, it's right angled, and we are wanting the angle, and we've got to involve the opposite and the adjacent again. So it's going to be tan again. So we're going to say tan of the angle we want is going to be the opposite, which is EB. So I'm just going to write 15 tan 35. If you want to write that decimal, that's fine. Divided by the adjacent, which was root 306. And if you want to write the decimal again, that's also okay. So you've got two choices. You can either say theta is arc tan, or tan to the minus 1, of exactly what this right hand side is after you've put it into the calculator. So I'm going to do that now. So you can either do it all as one by typing out tan to the minus 1 brackets, and then brackets again 15 tan 35 divided by root 306, but I think it's safer to at this point then put the decimals in. So we're going to get 10.50311,307 over 17.49285568. I'm going to do that on my calculator. I already have the 10.503 in there, so I'm just going to divide it by 17.49285568. That gives me tan to the minus 1 of 0.6004230107. Let's create a little bit more room. So if we do arc tan of that, or inverse tan, so arc tan of, and I'm going to use second ANS, which is already stored in my calculator, theta is going to be 30.98157,433, and it wants it to one decimal place here. So I'm going to round that here. So to one decimal place, the 8 would change the 9 to a 10. So this would be a 0, and then I'd have to carry the 1. So we're going to get theta as 31.0 degrees to one decimal place.
Question 20. We have a quadrilateral and we're given that CD is A. We're given DE is B. And FC is A minus B. We firstly have to express FE in terms of A and or B. So let's have a look. So if I want to make the journey from F to E, I can just go here plus here plus here. So we're going to have A minus B plus A plus B. And so we're just left with 2A. Okay, so that's the first part. I've got a suspicion that the second part's going to be a bit more tricky. So let's have a look. It says M is the midpoint of DE. Okay, so there we have it there. So straight away I'm going to put these in as half B. And it also says X is the point on FM such that Fx to Xm is in the ratio n to 1. So Fx to Xm is the ratio n to 1. And it says CXE is a straight line. So let's do a line going through here. And I'll mark this in red for you so you can see that's X is there. So let me think for a minute. We've got to work out the value of n. So I think because this is probably
giving you the answer, I would say that CX and CE would be the things I would find first. So I'm going to look for CE first and see if that's easy. So C to E is just going to be minus A plus B, because it's the opposite way round to this, because that was FC, this is CF, so it's going to be B minus A plus FE, which we've already got as 2A, so I'm just going to mark that in there. So we can say that CE is going to be B minus A plus 2A. And that's going to be A plus B. Well, that looks okay. Now I'm going to, up here, so I've got a bit more room, I'm going to just try and find CX. So let's have a think, what's the best way of getting from C to X? I would say that it'll be a good idea to go, and I'll just show you this. If I want to go from here to here, I'm going to go this route. So I kind of have to know what fx is as the vector first. So I think there's a couple of things I have to find first. I think as I'm going to be fx, I need to kind of find what fm is first. Okay, so a little side thing to find would be fm. And that is going to be 2a minus a half b, because all I've done is said, okay, I want to go from here to here, so I'm just going to go this way, 2a minus a half b, don't forget, because this is plus a half b going this way. So it would be fair to say that c to x is minus a plus b plus some multiple of 2a minus a half b here. And can you see what that multiple has to be? This is really important. We're told that the ratio of fx to xm is n to 1. So how many parts is that? Well, it's n plus 1 parts to that ratio, and fx has n of them. Okay, so that must be n out of n plus 1 is what fx has. Okay, so we know that here we've got to have n over n plus 1. Because that's almost kind of like saying what fraction of n plus 1 are we when we get from f to x. We're n out of n plus 1 of the way there. Okay, this x to m would be 1 over n plus 1, because xm has 1 part out of the n plus 1 parts altogether. So one last thing to think about is CE and CX are on the same line. Okay, so that means that their gradients must be multiples of each other. Okay, so we know that we have a plus b here, so we just have to multiply all of this out and hope that we get something in the form with an a plus a b and go from there. So we're going to have minus a plus b plus, I'm just going to multiply this out, that's 2n over n plus 1a minus n over 2n plus 1b. I'm going to put all the a terms together. So starting with this one, minus 1, because it's like the coefficients of the vector a, plus b, and I'll just have 1 minus n over. Okay, So let's just move that up a bit so we've got a bit more room. And neaten that bracket up a little bit. So this is really how we're going to get the value of n now. This is nice. It's just one lot of a plus b. Now, if we wanted to just get a plus b on this right hand side and take out something, can you see, to get that to happen, this and this would have to be the same number. Say it was 6, for example, then you could take a 6 out from the a 6 out from the b, and you'd get a multiple of a plus b, which is exactly what you want. So for that to happen, then all we've got to do is put the two coefficients of a and b equal to each other, i.e. this has to be equal to this. So, sorry it's taken so long, but this is probably the quickest way of doing this question. So let's think carefully. Let's get the difficult bits on one side. And let's get the easy numbers on the other. And then I'm going to times this by 2, top and bottom, so I get the denominators the same. So I'll have 4n plus n all over 2 lots of n plus 1 equals 2. Then I'm going to simplify. And then I'm just going to multiply out, cross multiply. So that's 2 lots of n plus 1. And so that's 5n equals 4 lots of n plus 1. So 5n equals 4n plus 4. Take 4n from both sides, so n equals 4. So that's the required answer for that question. So yeah, I think that's quite a difficult vectors question, as it turns out. I thought it was going to be easy, but it's actually quite complicated. I think it's not complicated in terms of the algebra, it's just complicated in terms of understanding why these two things have to be the same number, because that's the only way you can get them taken out as a factor, the same factor, to give a multiple of a plus b, which is what you wanted.